Let's go to Sudiksha. Sudiksha, you're here?
Yes, just give me a quick second. I'm going to share my screen.
Yeah, no problem. After Sudiksha, we have Rahul. Did I miss out on anyone else today? Anyone on the call? Hey, Sudiksha. Got it. Yeah, go ahead, Sudiksha.
Are you able to see my screen?
Yes, sweetheart. You want to click on the present button and then present? No, the share next to share, there's a present button.
Oh, okay.
Yeah, excellent. Go ahead.
Is it visible now?
Yes, perfect. Go ahead.
I'll start over. Hi, my name is Sudiksha Aaloori, and I'm a sophomore at Dallas High School. Today, I'm going to be presenting my thesis defense, and the title of my research project is The Use of Nanoparticles in the Treatment of FRDA. So my research question was, how can nanoparticles be used to treat Friedreich's ataxia? So first of all, what is FRDA? It is a rare neurodegenerative disease which damages the spinal cord and portions of the brain. My research is important because this disease currently has no cure yet. So if we can possibly use nanoparticles to deliver medicine or proteins straight to the damaged nerve cells, we could make a big difference in improving the lives of people with this rare disease. So for my literature review, I first would like to talk about the causes of Friedreich's ataxia. This disease is primarily caused by a mutation in a gene on chromosome 9, and these mutations lead to a damage in a gene in the mitochondria, which severely disables its function. And another interesting thing about this disease is that it's really rare because it is a autosomal recessive disorder, meaning both of the parents are not clinically affected by this disease. So they are essentially clinically unaffected, and they both carry a single variant of the FXN gene. And the child potentially can inherit a pathogenic variant from both carrier parents. Next, lipid nanoparticles. So lipid nanoparticles are tiny structures made of fats that can easily carry therapeutic proteins to where they're needed. So in my case, for example, the nerve cells, which are affected by the condition of FRDA. The reason why I chose this nanoparticle is because of its small size and its ability to navigate through the body, and that's what makes it an ideal choice for delivering medicine precisely and effectively. In addition, although there's not much clinical testing done on using lipid nanoparticles for the treatment for FRDA, it's being used specifically for drug delivery for other neurodegenerative diseases already. So that's what makes it even more ideal to be used for the treatment of Friedreich's ataxia. Next, for my results. So in order to get to my results, I first started by looking through different papers that have already kind of discussed potential treatment options for this disease. And this was kind of difficult because there are not many treatments for this disease as it's not curable. But a key treatment option was gene therapy. And that's what kind of urged me to look into lipid nanoparticles. So essentially for Friedreich's ataxia, there's not enough of a protein called frataxin, which causes problems in nerve cells. And to treat the disease, we can use a new treatment called RNA transcript therapy, also known as RTT, to give the cells that missing protein which they're lacking in. So you can basically package the protein into the lipid nanoparticles and use the lipid nanoparticles to deliver it to the specific affected nerve cells in the body due to Friedreich's ataxia. This experiment has already been tested on mice. So this lipid nanoparticles were injected through their veins or near their spine. And it was found that the cells took in the lipid nanoparticles and were able to turn the proteins into its active form within days. And even after the experiment, when the mice were tested, the protein was still detected in their body. So in short, we can use lipid nanoparticles to carry a specific protein to the nerve cells affected by Friedreich's ataxia, and this can provide as a potential treatment option. And in order to do this, we can use a combination of RNA transcript therapy, RTT, with the help of lipid nanoparticles. In conclusion, how can nanoparticles be used in curing Friedreich's ataxia? The answer is lipid nanoparticles could be used to carry specific proteins to the nerve cells affected by Friedreich's ataxia, providing a potential treatment option. My contributions to this topic: my paper clearly outlines ways nanoparticles can be used for curing Friedreich's ataxia and suggests it as a potential treatment method, and can possibly improve the lives of people with this incurable disease, just because this disease is being researched currently, but there is no cure. So if we can potentially use nanoparticles for treatment options, it could be helpful in bettering the lives of people who are currently diagnosed with this disease. Well, the next slide was just a thank you slide. I'd like to thank Gifted Gabber for this amazing, memorable experience. And Professor Christina was especially helpful because in the beginning, my topic was kind of really broad and all over the place. And she really helped me to narrow down my focus and provided me with a lot of helpful resources. And Professor Virgil, he really helped me because to be honest, I'm not very good of a writer, but with his class and teachings, I was able to become a better writer through the end of this journey. Thank you so much for listening.
Yeah, you want to stop sharing, Sudiksha? Great job, wonderful presentation. Dr. Christina, any question for her?
Yeah, great job. Very, very well done. I have a question. While you're doing your research on the lipid nanoparticles and so on, did you find any coatings, like organic coatings, which could be suitable for this type of nanoparticles, related, of course, to the application?
I'm actually looking into that right now, like diving a little bit more deep into that. Right now, I haven't really found anything. I actually was juggling between different nanoparticles and just narrowed my, I did research and wrote about different nanoparticles, but I narrowed it down to the lipid ones now. So I'm diving more deep into it.
Great, good, very good. Thank you.
Excellent.